All right, guys, so since we're not going to have time in class to review for our quiz tomorrow, this is a quick video that you can kind of listen to. Feel free to write the problems down on your own, maybe on a piece of paper, and practice it and pause the video and then come back and check to see if you did yours correctly. That would be a great way to study for your quiz. But I'm just going to run through the topics that are on our quiz tomorrow. So on our quiz tomorrow, it's basically over three things, right? So adding and subtracting polynomials, multiplying polynomials, and using those exponent rules that we learned, those two exponent rules, right? Deciding whether you add the exponents or multiply the exponents. So I'm just going to run through a few examples of each one of these topics so you can get a nice overview of the types of questions that are going to be asked on your quiz. Okay, so here we go. So topic number one is adding and subtracting polynomials. You definitely want to make sure that you understand and look at the question to decide whether you're adding, subtracting, or multiplying, because clearly I'm adding on this one, I'm subtracting on this one, and then I'm going to scroll down here, and then clearly you can see in these two polynomials there's no sign in between them. So this is clearly a multiplication problem example. Okay, so make sure you're looking at the question before you begin and ask yourself, is this adding, subtracting, or multiplying? Because how you handle the problem is going to depend on what kind of operation is happening between the two polynomials. Okay, so on the first one, we're just adding the two polynomials together, which remember that just means we can basically just drop the parentheses, right? The parentheses are really only here to tell us where one polynomial ends and the next one begins. And really what's happening is we are just distributing a understood positive one that's in the front of each parenthesis, which is why I can just drop the parentheses, because multiplying by a positive one is not going to change any of those terms. And then since we're adding, there's also an understood positive one in front of the second parenthesis. So everyone in that parenthesis is going to keep the same sign because we're just multiplying everybody by a positive one, right? So all my terms just come down. I can just drop the parentheses. And now it's just a combining like terms game, right? And I also want to make sure that I am writing my answer in standard form. The quiz will definitely ask you to do that. And remember, standard form is we will always want to write the terms with the highest degree first. So the degree is the exponent. So I want to get all my x squareds written first because those terms have the highest degree. All right, so we're just combining like terms. I have 3x squareds plus 4 more x squareds, which is going to give me 7x squareds. All right, and then we have negative 2x's minus 6 more x's, which is going to give us negative 8x's. And then, sorry, I'm taking the time to highlight here, positive 5 and a negative 2, that's going to give me positive 3 when I combine like terms. And there we have it, right? That is our new polynomial expression after we combined all our like terms. And you may also be asked on the quiz to classify, let me just write that down really quick, to classify what kind of polynomial this final answer is. So remember that's a two-part question. You're picking out the degree, which is the highest. So this would be a second degree. And because he has 3 terms, he's a second degree trinomial. Right, so if you're asked to do that on the quiz tomorrow, right, make sure you remember that the degree is just the highest exponent in the whole expression. And then if it has 1 term, it's a monomial. If it has 2 terms, it's a binomial. If it has 3 terms, it's a trinomial. And if it has 4 or more terms, we just refer to it as a polynomial. Okay. All right, let's move on to this guy. This is clearly a subtraction problem, and the only difference there is that this is now a negative 1 in front of that parenthesis. So when I distribute and multiply everybody by negative 1, that is going to change everyone's sign, because a negative 1 times a negative 9 is a positive 9x squared, and a negative 1 times a positive 4 is a negative 4, and a negative 1 times a negative 1x is a positive 1x. So just be really careful when you're subtracting. It's going to flip all the signs that come behind the minus sign because you're technically multiplying by a negative 1. My first polynomial isn't going to change though, because again, that's just a positive 1 sitting in the front. So we can essentially just bring down those terms. And voila, we got rid of all of our parentheses. Let me scooch this plus sign over. There we go. And now we can just combine like terms. And of course, the terms I want to add first are going to be the ones with the highest degree because I want my final answer in standard form. Right, and so that's going to give us negative 4x's plus 9x's will give us 5x squareds. And then let's see, we have our x's would come next. So I've got 5x's plus 1 more x. So I have positive 6x's. And then we have our constants, and they always go at the end because they have no degree, right? So positive 7 and negative 4 is going to give us positive 3. And that would be our final answer. And he's also a second degree trinomial, right? All right, and then the application questions that we did with the polynomials, especially with perimeter, right? So we're going to write an expression that represents the perimeter of this rectangle. Well, remember, perimeter means to add up all the sides. So technically speaking, we know that they only gave us the 2 sides, but we know that those 2 sides are just mirrored on the other side, right? So we know there's another 2x plus 3 over here, and there's another x squared plus x minus 1 for the length on the top. So we have 2 lengths and 2 widths. Now you can do one of 2 things like we did in class. If you want to, you can just combine like terms on the picture. Right? No need to sit here and write all the terms out because you're just going to combine them anyway. If you want to, then that's totally fine. But I'm just going to use my picture just to kind of save me some time. So I'm just going to go find all my like terms. So, and I want to make sure I pick the highest degree again. So I'm going to go find all those x squareds first. And it looks like I only have 1x squared on the top and 1x squared on the bottom, which is going to give me 2x squareds. Right? Then we want to go find all those x terms. Oops. Sorry, I'm trying to stay consistent with my colors here. So I've got a positive 1x, a positive 2x, another positive 2x, and another positive 1x. So if we combine all those x's, right, we get x plus 2 plus x plus 2. So it looks like that's a total of 6 x's. And then we want to go grab all of those constants, right? So I've got a negative 1, a positive 3, a negative 1, and a positive 3. And it looks like that's going to give us, what, 6 minus 2, so positive 4. And voila, that is the expression for our perimeter. You can put a p equals in front of it, or you can just leave it as 2x squared plus 6x plus 4 is totally fine. Right? But that would be the expression that represents the whole perimeter of the rectangle after we combined all our like terms. Okay? All right, so those are our examples of adding and subtracting polynomials. All right, now topic number 2 is multiplying polynomials. So remember in class we talked about 2 different ways you can handle this. When you're multiplying, right, that means we have to every term has to get multiplied to every other term in the other parenthesis. So you can either double distribute or distribute as many times as you need to. This 3x term, he has to get multiplied times all the terms over here. And this positive 2 also has to get multiplied times all the terms in that second parenthesis. And it's going to be a really big long, it's going to be 6 terms total, right, when we get done multiplying that all out. And then you're just going to combine them all together to simplify the mess, right? Or your other option was to create an array, right, where you do the box multiplication. I'm going to do that one for this particular problem just because it's a 2 by 3. Sorry, let me get a nice box there. Okay, so I know my first parenthesis has 2 terms, so that's 3x plus 2. And then let me move this, all these lines are kind of crazy. Let me kind of scooch that down so it looks a little not so crazy. Okay, and then we have our 3, I'm just gonna, I really should have done a better job of picking where I put those lines. Okay, that's okay. We're just going to leave it like that. All right, so our second parenthesis has 3 terms. So I'm going to write them down, 2x squared minus 4x. Make sure you keep the sign with his term, right? And so now I've created an array where I can just now multiply the top boxes and the side boxes to fill in the middle boxes. So I'm just going to do that really quick. Let's see, I'm going to change colors when I do that. So here we go. To get this box, we're going to multiply 3x times 2x squared, which is going to give us 6x cubed. Remember, we add the powers when we multiply x's. There's an understood 1 right here. And then to get this box, we multiply the positive 2 times the positive 2x squared, which gives me positive 4x squared. And then to get this box, we multiply the 3x times the negative 4x, which is going to give us negative 12x squared. Again, we add the powers because we're multiplying an x times another x. And then to get this box, we multiply the negative 4x times the positive 2, which is going to give us negative 8x. Then in the bottom left box, we're going to be multiplying the positive 5 times the positive 3x, which is going to give us positive 15x. And then in the bottom right-hand corner, we've got the positive 2 times the positive 5, which is positive 10. Right? Please notice that I have signs in all those boxes, well, except for the first one, which I totally could have. And now the great thing about this method, remember, is that most of the time, not 100% of the time, but most of the time, your like terms are going to lie on the diagonal if you've done it all correctly. So notice these are my x squareds, these are my x's, and then there's only one x cubed and one constant, right? And so I'm going to be able to combine along that diagonal and get my nice friendly answer at the end. So I only have one x cubed term, so he's just going to come over. I have a positive 4x squareds and negative 12x squared, so that's going to give me negative 8x squareds when we combine. And then I have negative 8x's plus 15x's, which will give us positive 7x's when we combine. And then we have that plus 10 constant, right? And that is our final answer after we multiply. Okay. Again, that's if you want to do the box method. Okay, you don't have to. I'm going to do the distributing method on this next one, okay? All right, so on this one, a lot of people mess this one up because they want to try to take this 2 and give it to everybody inside, but you can only do that if these are all factors, and these aren't factors. There's a plus sign, so these are terms, and you're not allowed to do it if there's terms inside, only factors. So what you want to do is ask yourself, what does this square mean? Well, remember, when you square something, that means you're taking all of this and multiplying it by itself. So what the first thing you want to do is expand and rewrite the problem as 3x plus 2 times itself, because that's what squaring means. And now we have a binomial times a binomial. And again, if you want to do the box method, you totally can, right? This is just going to be a 2 by 2, so you're just going to write 3x plus 2, 3x plus 2. Sorry, it's really sloppy. And then fill it in just like we did a second ago. On this, I'm going to do the distributive method, though, here, in case anybody's interested in doing it that way. So here we go. We are going to take our first term in this parenthesis, and he has to get multiplied or distributed to both terms in the other parenthesis. So 3x times 3x gives me 9x squared, and 3x times positive 2 gives me positive 6x. Make sure you put plus and minus signs to delineate whether it's a positive or negative term, okay? Then we are going to take, let me change, oops. Sorry, I'm trying to change colors here. Then we want to take that positive 2, and he also has to get multiplied times both terms over here. So positive 2 times 3x is another positive 6x, and positive 2 times positive 2 is positive 4. So we've got rid of the parentheses by multiplying everybody together, and then of course you're going to look for like terms, which are typically going to be in the middle, and we want to get those guys combined. So 9x squared, and then plus 12 total x's in the middle, and then bring down the plus 4 constant. And there you go. And you get the exact same answer with the box method. Okay? All right, I threw number 3 on here because this is like a combo. This is a combo of multiplying and adding and subtracting. So here we go. We definitely have parentheses, so we want to make sure that we're paying attention to the number multiplier that's in the front. So we are going to distribute, right? And that's going to give us, what, 2 times 4x is going to give us 8x. And then 2 times negative 5 is going to give us negative 10 or minus 10. But then I have another parenthesis, and what number's in front of him, right? He has a -1 multiplier, even though I know this is a subtraction problem, but just like we talked about above, a subtraction problem means there's technically a -1 multiplier, so everybody behind it has to get multiplied by -1, which essentially just changes the signs, right? That's going to give us -2x plus 7. All right, so we multiplied to get rid of the parentheses because they had multipliers in front of them. Now we're going to combine like terms to finish simplifying the problem. And as you can see, we've got 8x's and -2x's, which should give us 6x's, right? And then we have -10 plus 7, which is going to give us -3. And that is going to be our final answer, which would be a first-degree binomial, by the way. Okay? All right, then we had another rectangle application question, but this one is asking you to find the area, right here, area, right? And of course, area is not the same thing as perimeter, right? Area is length times width, right? So that's exactly what we're going to do on this problem. Let me move that down here. There we go. Hold on one sec. Sorry, I'm going to just write that. All right, so remember, area is length times width. And they give you the length and the width. And it doesn't matter which is which, right? You can make either one of them the length and either one of them the width. It doesn't matter because we're just multiplying them together anyway. So what I'm going to do is just simply take our length times width formula, and we're just going to multiply those binomials together. If 2x minus 5 is my length, and the x plus 3 is my width, or vice versa, again, the order doesn't matter, then it's just right back to a multiplication of binomials. So this is exactly what we just did right here on example number 2, right? So don't freak out if it's just attached to a rectangle. It's the same exact question we've been doing. And so now we are going to treat it exactly like we just did a second ago. So we need to multiply. We got to take that first term and multiply him times each term in the other parenthesis, right? What's that going to give us? 2x squared, right? Because 2x times x. And then 2x times positive 3 is going to give us positive 6x. Then we need to take the -5, and we need to multiply him times every term in that parenthesis, which is going to give us -5x minus 15. And the cool thing is, right, again, we're going to have like terms, and they're usually always in the middle like this, right? And that's going to give us our final answer that the area is 2x squared. What's that going to give us? Plus 1x minus 15. Okay. All right, our very last example is what we did earlier this week, right? And talking about exponents and how to handle lots of exponents. And please remember, we only learned 2 rules, right? These are the only 2 rules, right? If you have a power outside a set of parentheses, then that power has to get multiplied times every other power, right? So power to a power, you multiply the powers, but only if there's a number outside the parentheses. Number 1, I have a bunch of parentheses, but you'll notice I don't have any powers actually outside the parentheses. So this is just a plain old multiplication problem. The parentheses are just here to tell me where one expression begins and the other one ends. If you want, I can totally drop, you don't have to do this, but you can totally drop every single one of the parentheses, and I can also split all the factors up because these are all separate factors that are getting multiplied together. So for some people, it might be handy to be like, okay, the 3 and the 4, these are just numbers. Remember, this is not a 3x. This is 3 times x, right? It's just we shove them together to show multiplication, but they're actually totally separate factors, right? So 3 and 4 can get multiplied together just like normal everyday numbers, but then we have an x squared and an x, and remember that x has an understood 1 power, right? I'm just getting myself set up here. Then we have an x squared and another x squared, and then we have a z to the 4th and a z cubed, right? So here we go. We're just going to multiply our numbers together. So 3 times 4 is 12, And then we're trying to merge all the x's together. So we want to figure out how many total x's do we have. So this is where you add the exponents. I'm going to put a little note here, right? When you're merging bases, because I have an x on the over here, I've got an x way over here, and I've got an x way over here, and I want to merge them together as one cohesive x. That is when you add the exponents, right? So that's going to give us 3 total x's, so x cubed. Then I have a y squared and a y squared, so that's 4 total y's in our chain of multiplication. And then we have 7 total z's in our chain. And that would be our final answer. Okay, just multiplying. We are doing a multiplication problem, but the shortcut to multiplying exponents is just to simply add the powers to figure out how many total chains or total values are in that multiplication chain. Okay, now over here, we've got the totally different scenario, right? This is what I was talking about a second ago. We have a power, all the powers inside are getting raised to the 3rd power on the outside. So I don't want to forget that this 2 has an understood 1, right? So because I have powers being raised to another power, this is where we multiply the exponents, right? Multiply the exponents. You only do that when you have a power on the outside. That's the only time you're going to do that. So now I'm just going to rewrite what I have. I have a -2, and I'm going to keep them in parentheses. Remember, parentheses are important. And of course, 1 times 3 is 3. And then x to the 2 times 3, which is 6. And y to the 3 times 3, which is 9. And I'm totally cool with you leaving your answer just like that. Or if you want to simplify that -2 cubed and type that in your calculator, it's going to tell you that that's -8, right? Because that's -2 times -2 times -2. So if you want to simplify that number hanging out in the front, you're more than welcome to. But I will take either answer. Okay? All right. Let me box this answer over here. All right, now this one we actually are going to be talking about on the day of the quiz, right? This is no different than what we just talked about. The only difference is it's a fraction, right? But I still have a power on the outside, and so we do it exactly like we just did on this one. Everybody has to get the power on the inside. That's why there's a set of parentheses. The only difference is the fraction, so that just means... So that just means that everybody in the numerator and the denominator have to get the fraction. So, I'm sorry, the exponent. So 2 has to get the 4, the x gets the 4, and the y squared in the denominator gets the 4, right? And don't forget, these currently have 1s, right? The 2 and the x, they don't have powers, so they're understood little 1s there, right? Okay, now, so let's see, let's write all that out. So this is going to be 2 to the 4th, because 1 times 4 is 4. X to the 4th, because 1 times 4 is 4. And then in my denominator, it would be y, but I have 2 times 4, so I'm going to get an 8 there, because we multiply the powers when you have a power on the outside of the parentheses. And that's it. That's all I have to do is just give everybody the 4th power. It doesn't matter if it's a fraction. Every factor gets the 4th power. And you can leave your answer like that. Or if you want to type in 2 to the 4th power on your calculator, you'll find out that that's 16, right? Because it's 2 times 2 times 2 times 2. So I would take the answer either way. Okay? All right. I hope that helps you out and helps you get ready for your quiz tomorrow. And I will see you soon.